Assalamu alaikum. Today we are here to discuss the clippers and clampers, and then we will design these clippers and clampers in COMSOL Multiphysics to get the input and output waveform. The layout of the presentation is: first we will discuss the clippers, then we will discuss the clampers, and then we will see how these clippers and clampers are working. Then after that we will finally get the um, we will design these clippers and clampers in COMSOL Multiphysics. The layout of the presentation will be: first we will discuss the clippers, then clampers, then we will design COMSOL Multiphysics, in which we will discuss how input is provided and how we will get the output waveform. So both the waveform will be compared in one graph. So designing in the COMSOL Multiphysics will be crucial in this work. Clippers are basically the circuit which are used to clip the input wave. One part of the wave will be clipped off. Um, for example, if we are considering a circuit in which Vi input is provided, Vi input is basically the input wave. Here we have considered the pulse wave and also a sine wave. When we are providing this input wave to this circuit, which is the resistor diode based circuit, so the negative cycle will be clipped off. As during positive cycle, this diode will be short circuited and all the voltage will drop across resistor R. So we will get V naught signal at the output, and the signal will be like this one, and we obtained a pulse at the output. When we are applying the negative half cycle, then this diode will act as reverse bias, and the voltage will drop across this open circuit due to the reverse bias of the diode. So no voltage will drop across R, then output will be 0. So the signal will be clipped off. So this is called the um, uh, clipper circuit. Most of the time these clippers are the examples of the clippers are the half wave rectifiers. These are also called as limiter, also slicers, and most common examples are the half wave rectifiers. Similarly, you can see over here that we are providing the sinusoidal wave, and also we have included a voltage supplied in the supplies in the circuit. So additional signal will appear in the output wave with a voltage supply of V. Then positive and negative clippers are obtained when you are connecting the diode in such a way that the positive cycle are clipped off. Then these are called the positive clippers. In that case, we connect the diode in opposite direction, and when we applying the positive cycle, this uh, diode will behave as open circuit, and the whole voltage drop across this diode and no voltage will drop across resistor R. And for positive cycle, no signal will appear at the output side, but for the negative half cycle, this diode will act as short circuit and all the voltage drop across resistor and negative signal will appear at the output side. Similarly, negative clippers are those clippers in which the negative half cycle are clipped off. In that case, the diode is connected in such a way that when we are applying the positive signal, then this diode behave as short circuit and current will flow through the short circuited diode and voltage will drop across resistor R and you will obtain a positive half cycle at the output. Now, when we are applying the negative half cycle, then this diode will behave as open circuit and signal will drop at the will signal the whole voltage will drop across this diode and no voltage will drop across this resistor and no current will flow and then no resistor will voltage will drop across this resistor R and output signal will be 0. Now, let's start in COMSOL Multiphysics. Now we are considering these clippers and designing these clippers in COMSOL Multiphysics. Later on, we will discuss the clampers and then we will design clampers in the COMSOL Multiphysics. At this stage, we are considering only the clippers and then input and output wave of these clippers. So here these are the results which will be obtained. First we will design and this is the final result, but we will design whole circuits from the scratch. So this is the input signal which is being applied across the circuit, which we called it as VI in that initial circuit. So we have applied this signal of 10 amplitude of wave and with 100 millisecond. We also vary different frequencies. So this is the input signal and we have obtained the this signal at the output. So you can see that the positive side of the signal is clipped off. So this is the positive clipper. So let's start it from the scratch. I am opening a new project here. You can start in two ways. You can start with the model wizard and also a blank model. It's up to you how you are. If you are familiar with the COMSOL multiphysics, then you can start with the blank model, or you can use also the model wizard. In model wizard, we will see different options as you can select from 3D to 0D. So as we are not using the multiphysics, so we can use 0D or 1D direction. As I have used electrical circuit earlier, so there is recently used electric circuit module. So you can also go into AC/DC module and there is a subheading of subsection of electric circuit. You can double click and add it into the physics interface, then click study. After that you are using the time dependent, and so we will consider the time dependent study. So this I have created in earlier model, so I am not saving that one. So this will take some short time and a COMSOL multiphysics interface will appear in a short time. Now this interface is appeared. You can see model builder, setting window, graphics design, and in this you can see the add physics, made material, and add study portions. This is the process what we are doing. So um, as we are considering the circuit, now we will add the components in the circuit portion, electric circuit portion. First we will insert the voltage source, then after that the diode will appear, then the resistor. Also there is a ground node, ground symbol, so no need to add this ground element. So if we look at the circuit diagram, then this will be the input sinusoidal wave. So one end of the source is connected to one point and the other end is connected to the zero. So this will be the input sinusoidal wave. So one end of the source is connected to one point and the other end is connected to the zero. So for the electric source, we are connecting P with one and other end is the other node is 2. Similarly, one is connected, one of the source is connected with the P side of the diode. So, and the other end of the diode is connected with the node 2. This one. Okay. Then there is a resistor. One end of the resistor is connected with 2 and other is end of the resistor is connected with 0, and uh, you can see ground is also connected with 0, and the other end and second end of the input voltage is also connected with the 0. So we give 0 to second node of the resistor, then ground and the second part end of the input supply. So here the resistor 2 is this one, and the second end is 0. Similarly, voltage supply, the second end of the voltage input voltage supply is 0, and the uh, ground is connected with the 0 node. So here we will add this inputs wave as sinusoidal wave. So study, let's see the output wave. So we are applying uh, the range is 0 from 0 to 100, and using the millisecond unit, and also we can use the 0.0.5 step size of 0.5. So the frequency is set at 30. So also the input wave is input amplitude is 50 volt. So you can move towards the time dependent. So the range is 0 to 100, and we have a step size of 0.1 so a millisecond. So let's compute this one. Okay, now to see the results, click on the results, and um, here in the results, click on the 1D plot. In the 1D plot, you can click on the global. So add the expression, click on the device, and for the y-axis uh, we are applying the input from this wave. You can plot this one and you will see. Okay, we are interested in the input signal which is being applied to the circuit through V1 source, the sinusoidal source. So we are adding this expression in the wave, and then we are plotting this one. Then you will see that an input signal of 50 frequency is appearing in the graphical window with total time of 100 millisecond, as we have already used this one. Now the output wave will be clipped off. So part of the input signal will be clipped off in this circuit. So you can see over here, this is the half wave rectifier and the negative clipper. This signal will be clipped off. So let's see. Okay, now we are adding the output signal. The output will be appear across the resistor R. So we are considering the output signal across this one. Then we are plotting this one, and you can see that this green color is appeared and the negative half cycle is clipped off. This green color is going up to 50. Then a straight line is appearing, negative sign side is clipped off. You can change the coloring and other parameters. So you can change this with dash lines, or you can change also the color as well. Results, input signal is clipped off at the output side. So thank you very much for your patience. Inshallah, we will see the clamper in the next video, how they are working and how we can design in the COMSOL multiphysics. Thank you.